Okay, the Perfect Square College Algebra Lecture Section 1.3 has to do with linear models. And this really has to do with solving word problems that involve linear models or linear equations. Before we get into some actual word problems, let's talk about how you could solve literal equations. I've got a couple of complicated examples here. So for instance, let's say you had 1 over a equals 1 over b minus 1 over c, and you wanted to solve for c. It says here to solve for c. Well, the first thing I would do is I would eliminate the denominators by getting my lowest common denominator, which is ABC. And then I would multiply each of these three terms by ABC. So here, if you multiply 1 over a by ABC, the a's cancel and you get BC. Here, if you multiply 1 over b by ABC, the b's cancel and you get AC. And then here, if you multiply 1 over c by ABC, the c's cancel and you get a minus AB. Now, since we want to solve for c, let's get the two terms that have c in them to the same side of the equal sign. So what I'm going to do is I'm going to transpose this term over to the other side. And remember, when I do that, it becomes minus. So if I move this to the other side, I get BC minus AC. And then over here, I still have the minus AB. And then what that allows me to do is, since both of these terms have a factor of c in them, I can factor c out of this. And when I factor c out of each term, it's going to give me b in the first term and minus a in the second term. And then all I have to do from there to get c is I can just divide both sides by b minus a. So I just take both sides and divide by b minus a. And then by doing that, I'm going to get c equals minus ab over b minus a. Now there is another way to write it. If you don't want that negative to be in the numerator, you actually could factor a negative 1 outside of b minus a. And when you factor a negative 1 out, that becomes a minus b. And then negative 1 over negative 1 is positive 1. So basically the negative 1's cancel each other and you just get positive a over a minus b. So either way is correct. It's just that it depends on if you need to get rid of that negative or not. Also, a cannot equal b because that would give you 0 in the denominator. So that's just something to remember. On this next one, I didn't give you the domain, but of course x can't be a or x can't be negative a. Otherwise, you would get 0 in the denominator. Also over here, a, b, and c can't be 0 either, because if they were 0, one of these would be dividing by 0. Okay, so here I have a proportion. We talked about that earlier. With proportions, you can cross multiply. So I'm just going to take b plus c and multiply it by x minus a on the left. And then on the right, I'm going to take b minus c and multiply it by x plus a. So since that's a proportion, I can cross multiply. Now, you're just going to FOIL. B times x is bx. B times minus a is minus ab. C times x is cx. C times minus a is minus ac. Over here, you have some similar terms. B times x is bx. B times a is ab. Minus c times x is minus cx, and a times minus c times a is minus ac. Now, notice that anytime you have terms that are exactly the same on each side of the equal sign, they're going to cancel. And if you'll notice here, I actually have a bx, a positive bx, and a positive bx. So if I were to subtract bx from both sides, it would cancel them here and here. I also have a minus AC over here and a minus AC over here. And if I add AC to both sides, it would simply just cancel them out. So that would leave me with minus AB plus CX on this side, and then AB minus CX on this side. Now, I want to solve for X. So let's get the two terms that have the X in it. So if I have a CX here, and a minus cx here, then what I could do is I could actually add cx to both sides. If I add cx there, and don't really have much room here, but let's just say I add cx here, then what you're going to get here, cx plus cx is 2cx, and then of course these are just going to cancel each other out. And so you're going to have just the AB. Also with the minus AB, what if I added AB to both sides? Say I add AB here to minus AB, well that's just going to cancel those out. And then if you say AB plus AB over here, then you're going to get 2AB. Now, we want to solve for x. So if you have 2c times x, then just divide both sides by 2c and you'll get x by itself. So divide this side by 2c and you just get x. Divide this side by 2c and you get 2ab divided by 2c. But then remember 2 over 2 is 1, so we can cancel that and get that x is equal to ab over c. And so that's how you can solve some linear, some literal equations for variables. And you might run into other equations somewhere down the road that you might have to solve, like if you work for engineering where you're solving for current problems, where I is the current, R is resistance, and V is the voltage, or if you're solving simple interest problems where you're solving for interest or principal or rate or time, you may have to manipulate an equation. Okay, now I want to go ahead and start working with some word problems, and I've divided these up into sections, so we'll see how many sections it takes me to finish this. But I've got interest problems, I've got mixture and money problems, I've got uniform motion problems, and I've got work and other problems as well. So we'll start with the first one here, which is the interest problems, and we'll do those first. So now, let's look at number 1 here. A total of $10,000 is deposited into 2 simple interest accounts. On one account, the annual rate is 9.5%. On the second account, the annual rate is 13%. How much should be invested in each account so that the total annual interest rate earned is 10.9%? So here's what I've done. I've drawn a table here to show you we want to know how much should be invested at 9.5%. We want to know how much should be invested at 13%. And we know that the total investment should earn us 10.9%. So what I'm going to do is, since I know the total investment is $10,000, then whatever I invest at the 9.5%, we'll call it X. If I invest X in that amount, well, I know that the two amounts that I invest must add up to equal $10,000. So if I take $10,000 and subtract X out of it, then I'm left with 10,000 minus X to invest at 13%. So that's how I determine my variables. Let X be the amount at 9.5%, and then 10,000 less X is the amount invested at the 13%. Now, we're given the rates that we're going to earn. We're going to earn a 9.5% rate. You have to write that as decimal. And a 13% rate. That's what we're going to earn on the two investments. Now, since this is for 1 year and interest is principal times rate times time, I can just do principal times rate because time is 1 for 1 year. So principal times rate, here the principal is X, the rate is 0.095, so the interest that I earned would be 0.095X. Here, the principal is 10,000 minus X, the rate is 0.13, and you're going to have 0.13 times 10,000 minus X. Now, we want the total interest earned to be 10.9%. Well, that means 10.9% of the total invested. So the total invested is $10,000. And if I take 10.9% of $10,000, I get 1,090. All I have to do is multiply it by 0.109. So I know the total interest earned must be $1,090. Now, So since this is the interest earned on the first account, this is the interest earned on the second account, when I add those two numbers together, so if I add these two numbers together, they must equal $1,090. So all I have to do is solve this linear equation now. So here, let's distribute 0.13 through here. 0.13 times 10,000 is 1,300. 0.13 times minus x is minus 0.13x. Now, grab a calculator if you need to, but if you take 0.095x minus 0.13x, you're actually going to get a negative. Actually, I skipped a step here. You're going to get a negative 0.035x. And then when you subtract 1,300 from 1,090, you're going to actually get a negative $210. Okay, but since this has a negative on this side and this has a negative on this side, if I multiply both sides by -1, the negatives disappear, and I can just say that's 0.035x equals 210. And then all I have to do is divide both sides by 0.035. So if you take 210 and divide it by 0.035, you get x equals 6,000, which means 6,000 at 9.5%. And then remember, the 13% investment is 10,000 minus x. So if I take 10,000 minus 6,000, I get 4,000 invested at 13%. So those are the two values of your investment. Okay, the next one is similar. You're going to have two investments. The first investment is going to earn a rate of 12.6%, but the other company lost 5%. Now here they told us the total earnings. Up here they didn't tell us, they just told us the percent, and we were able to calculate the total earnings, which was 1,090. But here we're given the total earnings is 104. So we're going to do it very similar to what we did the first problem. We have an amount invested at 9.5%, we'll call that x. We have an amount invested at 13%, we'll call that 12,000 minus x, because we know the total amount invested is 12,000. So we know the rate we earned was 12.6%, and decimal that's 0.126. We also know we lost 5% on the other investment. So the total interest earned on the first investment would be 0.126x. The investment on the second investment is actually going to be a negative because we lost money. So we're going to have negative 0.05 times 12,000 minus x. And remember, when you add these two together, they have to represent the total amount earned, which is $104. So we're going to add these two together. Basically, we're taking the 0.126x, we're adding it to the negative 0.05 times 12,000 minus x. And when I say add, you're actually adding a negative, so it's really subtraction. So you have negative 0.05 times 12,000, that's 600. You have negative 0.05 times negative x, and that's 0.05x. And then that has to equal the total 104. Now when you combine these together, 0.126x minus 0.05x is I'm sorry, we're adding 0.05x. You're going to get 0.176x. And then if you add 600 to both sides, 104 plus 600 is 704. And then when you divide both sides by 0.176, you're going to get 4,000. So x equals $4,000. So $4,000 was invested at 12.6%, and then 12,000 minus 4,000 gives me 8,000 that we lost at the 5% rate. And so, you know, those two investments add up to 12,000, and since I gained 12.6% of this and lost 5% of this, you can easily figure out that those two do equate to a total gain of $104. Okay? Now we'll move on in the next video, we'll move on to mixture and money problems.